Hi, welcome to Deep Learning ICP2. The objective of this ICP is to learn about the neural networks, activation functions, loss functions, and immense data set of keras. The software used are Python 3, and I have used Jupyter Notebook here. And the libraries that are required are Pandas for visualization, keras, and TensorFlow. Uh, the first one is like the first objective is like using the history object in the source code. We are going to plot the loss and accuracy of the training data and also the validation data. The first objective is importing all these libraries required, and the next one is we are going to train the data, and the next one is we are going to process the data, like we are going to convert the each shape to like 28 by 28 to 784 dimensional in a single feature. And we could see that the dimensional data is 784 here. And the next one is we are going to convert the data like the data to float and the scale values of 0 and 1. We are going to we are going to convert both the trained data as well as the test data. And the next objective is scaling the data, both the trained data and the test data, with a scaling factor of 255. And the next one is like we are trying to encode the data with the help of one hot encoding. Is like it's we are doing the same thing like just like the label encoder. And the next objective is like creating the network that is the model is going to be the sequential model, and we are creating this input layer as with activation type as ReLU, and two more layers where one layer has got ReLU and one layer has got softmax. And next one is like we are trying to compile the model with the optimizer that we are using is RMS property, and the catalogically cross entropy is the loss thing. And the metrics we are going to calculate is the accuracy as well as the loss here. And so we are trying to fit that model to the history object here. And so we are just calculating all the epoch values the for all the that are trained on these 60,000 samples, and we are going to validate on the trained data, that is 10,000 samples. And thereby we are trying to plot the accuracy graph here. The accuracy graph will be like the accuracy taken on y-axis and as well as the epoch taken on x-axis, and here it is the graph that like here we'll be able to see that graph for both the trained data as well as the test data. And the same thing will happen with the loss, where we are taking loss on y-axis and epoch on x-axis here, and the same will be plotted for both the trained data as well as the test data. And now we'll be able to see the evaluation of the test data with the help by calculating both the loss as well as the accuracy. And the loss which we got is like 0.144, and the accuracy is going to be 0.955. and after that the image the image of the digit from that test data, and it's going to be predicted. And the predicted value, as you can see here, the predicted digit is like 2. And so this is the first part and the second part of the question. Like the first part is like we are going to calculate both the accuracy as well as the loss graphs, and the second part is like visualizing this image as well as predicting the image. So the image is predicted as 2 here. And thereby we are moving to the third question. The third question is just like the same, like we are going to we are going to again train the data, process the data, and we are just trying to encode we are going to convert it like to float, as well as we are going to scale the data. And we are going to encode with the help of one hot encoding, and same thing, but what we are doing is like we are going to add two more dense layers here, where one is the one has got the activation layer as TANH, and the second one we are and the second layer has got sigmoid here, and again we are doing the same thing, like we are initiating the optimizer loss value as well as we are calculating the matrix, and after fitting up to the model we are again calculating the accuracy by taking accuracy on y-axis and approach on x-axis, and the same is happening again with again for calculating the loss also, where the loss is taken on y-axis and the approach is taken on x-axis, and finally we are going to calculate the loss as well as the accuracy, and the loss value, as you can see here, the loss value is this and the accuracy value is this one. So and again we are doing the same thing, like we are predicting the digit that we have obtained. So and the point is like from the first question to the from the second question, or from first and second question to the third question, what we could infer is like here if you see, the loss is 0.144 and the accuracy is 0.955 only, whereas here the accuracy has got increased from 0.955 to 0.98, which shows us like when we increase the dense layers the model has got more accuracy. Now and the loss has got decreased. And now coming to the fourth question, the objective of the fourth question is in the first and the second question, what we have done is we have scaled the data. So instead of scaling the data, just like in the third question, we are removing the scaling part here, and the rest remains the same. The first part is loading the data and training the data and encoding and converting into float. Rest all remains the same. The only objective is like we are going to command this part of the scaling, and we are remaining we are setting the dense layers as it is, and we are just trying to fit the data to the model, and we are trying to calculate all the epoch values of these 10,000 samples, and thereby we are plotting the model accuracy for both the train and the test data by taking accuracy on y-axis and epoch on x-axis, and thereby we got this model accuracy graph. And then again, we are calculating the loss value for both the train and the test data by taking loss value on y-axis and epoch on x-axis. And finally, we are going to calculate the loss and accuracy for this model, saying that the loss is 0.173 and accuracy is got the 0.945. Here, what we could observe is like before the accuracy was 0.98, whereas after the scaling is removed from this by like we have removed the scaling in this question by commenting this part. So after the scaling has got removed, the accuracy has got decreased. So from here we can infer that the as the scaling of the data is done, the accuracy will increase. So this we could infer from this part, and then again we are doing the digit prediction, where the digit is predicted as 1. And thank you.